The first algorithm we are going to unravel is merge sort. Merge sort is a comparison-based sorting algorithm, and it actually hits the bound of how fast a comparison-based sorting algorithm can run. So, I have a question. What is the best way to merge two sorted lists? Let's take a look at an example. Let's place a pointer at the start of each list, and let's keep another variable to store the finished product. We will compare the values of each list at their pointers, and then we will move the smaller value into our array. Then we will slide the pointer of the element we just moved to the next position in its array. We repeat this process until one of our pointers has left its array. At this point, we can just insert the remaining elements into the final array. This algorithm is the foundation of merge sort. Honestly, if you know this, you're 90% there. Next, let's look at an unsorted list, the godless heathen in the world of computer science. The first step of merge sort is to continually split a list in half until it is made up of n lists, each with one element. After all, a list with only one item is technically sorted. Then we can begin to merge them back together. And because each list is sorted, we can run our merging algorithm. And we do this until we put all the individual lists back together. At this point, our list is no longer godless, but sorted and divine. Now, before we take a look at the code, take a moment to think about how you would implement this. Try to stretch your noodle. It's a good exercise. Alright, amigos míos, let's write the code together. In this case, we're going to be using JavaScript because it's pretty easy to run anywhere. I also had a certain chatbot write me two methods, one to generate a random array and another one to check if an array is sorted. They're a little wordy, but hey, I didn't write them. So let's come over here and write our methods. The first one that we're going to take a look at is the merge sort, which we covered first, that merges two sorted arrays together. And here in our method header, we have an array. We have a start pointer, a middle pointer, and an end pointer. So instead of taking two different sorted arrays and merging them into one, we're actually starting with one array that has two sorted arrays in it that we need to combine. An example of this would be 1, 4, and 5, followed by 2 and 3. Now this is unsorted, but the 2 and the 3 are sorted, and the 1, 4, and 5 are sorted. So in this case, our start would be at the 1 index, the end would be at the index of 3, and the middle would be at the index of 5. And then we would combine this into a sorted array. So the first step in this function is to get the right and left sides of this array. And we can do that by using JavaScript slice. Almost all languages have this function. So at this point, we have a left array to work with and a right array, and we can actually use our original array as our final output. So now we have a separate reference to our left side and our right side, and we can just modify our original array in place. So the next thing that we are going to do is place a starting pointer on our left and right side arrays, and then we are going to create another pointer k for our original array. And these are just placeholders to know where we are at in each array. So then we begin while k is less than e, or while we still have items to sort in this original array, we're going to continue our little algorithm. The next thing that we are going to do is compare the pointers in the left and right array to determine which value is smaller, and then we are going to insert it into our original array at k. So in this case, we're going to take the element from our right array and insert it into our original array if the left array has no more items or the item in the left array is greater than our item in the right side array. Otherwise, we're going to insert the left side element. After we have inserted the element, we are going to move our original array's pointer forward 1. And after this loop is finished executing, after we have run through our original array from start to end, we are going to return the start and end indexes. So this is it for our merge function. This will take an array like this and turn it into something sorted like this. So now let's get started in on our actual merge sort function. And this is what the method stub is going to look like. So we are a function that takes an array, obviously. It's going to be unsorted, we assume. We take a start index and an end index, because once again, we are only modifying our original array in place. We don't want to create a bunch of separate arrays because that increases our memory usage. Another thing about this function is that it is going to be a recursive function. Merge sort is much easier to implement this way and is pretty simple once you get your head around it. So the first thing that we're going to do is check our base case, which is if the start index is less than the end index. And what this base case is doing is ensuring that the subarray that we are looking at in between S and E is an array of at least 2 elements, because if it has 2 elements, then we need to sort them. The next thing that we are going to do, if our array has more than 1 element, is find the middle of it. We are going to split it in half. This is what that looks like. And now that we have the middle, we are going to recursively call merge sort on the left side and on the right side. Let's go through an actual example to understand better what is going on here. A lot of people are uncomfortable with recursion because they haven't used it very much. So the first thing that we are going to do is call merge sort on this array. We are then going to call merge sort on the left half, which is 3 and 1. We then call merge sort on the left half of this, which is 3. 3 is only 1 element, so we go up 1 level. We then call merge sort on the right side, which is 1. 1 is only 1 element, so we go up back to this level. We are then going to call merge on this. And after we call merge on this, we are going to have a sorted array on the left side. We are then going to come back to this level, and we are going to make our way down the right side. The right side is going to give us 2 and 0. We're going to go down the left side, which gives us 2, which is 1 element. We go up 1 level, and we take the right side, which is 0. 0 contains only 1 element, so we return. We come back here, and we call merge on these 2. After we call merge, we have a sorted right side array, 0 and 2, and then we come all the way back up to the top level, and we are going to merge these elements together, which gives us 0, 2, 1, 3. If this is still unclear, I highly recommend going through an example with pen and paper, going down through each level and really understanding how this algorithm works. And that is it. That is the merge sort algorithm. I've added a couple comments to the code here, and if you would like to download and play with the code, I will have a link in the description for the repository. But because I wrote this code, I am going to run the tester on it. So let's take a look. There we go, verifiably true. Nobody can ever fudge tests. That is the video. If you liked it, like and subscribe. If you did not like it, dislike the video and slander me in the comments. Anyways, goodbye and have a fantastic day.